Imagine a single moment that redefines the power of destruction. August 6, 1945, a flash of light over Hiroshima unleashes a force equivalent to 15,000 tons of TNT. We've all seen the iconic, terrifying images of the mushroom cloud, but what we rarely discuss is what happens on the ground in that instant to a human being. How does a force that powerful actually interact with the human body? What are the mechanics of this devastation, second by second? Today, we're going to break down the science behind one of history's most sobering events. Not for shock value, but for understanding. Because to prevent history from repeating itself, we must first comprehend its darkest chapters. Let's begin at the moment of detonation. In the first tenth of a second, an event of unimaginable intensity occurs. A fireball ignites, reaching a temperature of over 6,000 degrees Celsius. To put that into perspective, that is hotter than the surface of the sun. This creates a thermal pulse, a wave of intense heat that radiates outwards at the speed of light. Now, consider someone within a 1-kilometer radius of the hypocenter. Before they could even process what was happening, this wave of heat would strike them. Clothing would spontaneously ignite. Exposed skin would suffer third-degree flash burns in less than a single second. The heat is so intense and travels in such straight lines that it creates a chilling phenomenon known as nuclear shadows. Objects or people in the path of the thermal radiation absorb the heat, shielding the surfaces behind them. This resulted in permanent ghostly silhouettes being burned onto walls and steps haunting outlines of what was there just a moment before. Simultaneously with this thermal blast, another, more insidious force is released, an invisible storm of radiation. Primarily, this consists of gamma rays and neutrons, which are high-energy particles that travel vast distances. Unlike the thermal pulse that burns from the outside, this radiation penetrates deep into the body. As these particles pass through human tissue, they act like microscopic bullets, tearing through the very structure of our cells. They bombard DNA, shattering its delicate strands and causing cellular functions to break down. For those beyond the initial firestorm, perhaps 2 kilometers away, this was the primary danger. The initial dose of radiation would be delivered within seconds, but the effects would manifest over the following hours and days. This is acute radiation sickness. The body's ability to create new blood cells is compromised. The immune system collapses, and the lining of the digestive tract is destroyed. It's a systematic internal breakdown. Let's talk about the sheer scale of the energy involved. The little boy bomb released approximately 63 trillion joules of energy. A common misconception is that people close to the blast were melted or vaporized in the traditional sense. The reality is both more complex and more horrifying. The extreme instantaneous heat caused the moisture within human tissue to flash boil and expand explosively. This, combined with the charring of tissues from the thermal pulse, led to the near-total destruction of bodies at the hypocenter. It wasn't a slow melting process, but a violent, near-instantaneous obliteration through a combination of extreme heat and pressure. Survivors, who were within even 500 meters of the hypocenter, if they weren't killed instantly by the blast wave or fire, received a fatal dose of radiation. Many who seem to have survived the initial event succumbed to the invisible effects of acute radiation syndrome in the following weeks, while longer-term survivors faced a lifetime of increased cancer risks and other chronic health issues. The science behind this event is a stark reminder of our own capabilities, both for creation and destruction. Understanding the physics of what happened in Hiroshima is not about dwelling on the horror, but about respecting the power we've harnessed. This knowledge is crucial. It informs nuclear policy, disarmament treaties, and our collective global responsibility to ensure such weapons are never used again. By learning from the precise scientific realities of the past, we empower ourselves to build a safer future. This history isn't just a story. It's a data point that underscores the absolute necessity of peace and scientific ethics. Thank you for joining me for this deep dive into a difficult but important topic. If you found this explanation valuable and believe in the power of science to inform our history, please hit that like button and subscribe for more content. Let us know in the comments what aspect of this was new to you. Sharing knowledge is the first step toward a better world. Thanks for watching.